Hi everyone, this video is on the mixed exercise 9 question 8. So we have the function f of x, and in part A we want to find the first derivative of that. So we have both an exponential function and a quadratic. So first of all, if we want to differentiate an exponential function, we basically differentiate the power, and that comes down as a coefficient, and then we rewrite the function again. So 0.5x differentiates to 0.5, so then we write that here as a coefficient of the function itself, which is e to the power of 0.5x. So that's the derivative of the exponential function here, and then the quadratic obviously differentiates to minus 2x. So this is the answer to part A. Now for part B is an interesting one, and it says by evaluating f-6 and then f-7, show that the curve with the equation y is equal to f of x has a stationary point at x is equal to p, where p is between 6 and 7. Okay, so what the question is asking is that find f-6 and f-7, and then something interesting will happen as a result of that. And you need to mention that interesting thing and say why the stationary point of this curve between 6 and 7. So let's do that, and you're going to see what does this mean for us. So we need to find f-6 first. Okay, so from calculator, f-6 is equal to minus 1.9572 three decimal places, and f-7 is equal to 2.557, again to three decimal places. Now, what's interesting here is that the value of f-7 is less than 0, but the value of f-6 is less than 0, but f-7 is greater than 0. And how can this be related to the stationary point? So let me show you a quick diagram. This is not the exact diagram here, but the idea is that if you just look at this curve, for example, and if, let's say this is the stationary point, then consider this point, which has a negative y value, and then this point, which has a positive y coordinate. And as you can see, the stationary point is between those 2 points. So the idea is that a stationary point is always a point that on one side of that, the value of the first derivative is always negative, and on the other side of that is positive. So that's why the question is asking us to do this and to learn this important concept. In chapter 10, we are going to have a lot of questions around this area. But yeah, the idea is that if you have 2 points such that you get the value of the first derivative is positive for one of them and negative for the other one, then that means the x coordinate of the stationary point must be between those two values. So now we can say, as the sign changes between x is equal to 6 and x is equal to 7, and obviously the function, the first derivative is continuous, because being continuous is also very important, because if the function isn't continuous, then this condition won't hold, and that's because you are going to see some inconsistencies. For instance, the function, let's look at this function which is not continuous and just have an idea of why that could be a problem. So look at this function, it's not continuous, right? And you can't say that really, because sure, if you go to this point, you will get a positive value for the first derivative. But if you go to the left hand side, the first derivative is undefined for most of the values. So that's why being continuous is absolutely important. So yeah, since the first derivative is continuous, obviously the function is also continuous, and the first derivative is continuous, and also the value of f-6 is negative and f-7 is positive. So there must, the x coordinate of the stationary point in this question is referred to as p. It must be between 6 and 7 because the sign changes. So as the sign changes between x is equal to 6 and x is equal to 7, and obviously the function is continuous as well. Okay, that's it for this video, and thank you for watching.